Assalamu alaikum, dear students. Today we will be discussing the various factors that are affecting the elimination reactions. We have studied the elimination reactions in detail, that is the E1 reaction, E2 reaction, and E1CB reactions. They have different scores, different paths on which the reactions occur, and we get a substrate, we have a substrate, and then we use different conditions, different types of bases, different types of solvents to get our desired product. Uh, but today we will be discussing these factors which are affecting or which are deciding the pathway that these reactions will go further, that will proceed on. These factors are some like the substrate, the base, the solvent, the temperature, and so on. But we will discuss these one by one in detail. Number one, the effect of nucleophile. How the nucleophile will affect the course of a reaction. There is two types of reaction. One is the substitution and other is the elimination. There's a basic difference between the substitution and the elimination. In the substitution reaction, a nucleophile attacks on the carbon, leading to substitution. But in the elimination reaction, the nucleophile attack on the hydrogen, and that leads to the elimination. Now, when the two reactions are different, or the two attacks are different, so the nucleophile will have a strong effect on the course of reaction. Strong bases attack protons, so the more basic the nucleophile, the more is likely the elimination will occur. The proton is attacked by a strong base, so the strength of nucleophile, that will determine the course of the reaction. The stronger the base or the stronger the nucleophile, the more will be the chances that elimination will occur. Then the weaker is the base, more will be the chances that it will lead to the substitution reaction. So the strength of the base decides that which type of reaction is possible. Look into this example. We have the same substrate here. One is the base, or the nucleophile is ethanol. It's a weaker base or a weaker nucleophile, and it's lead to substitution reaction. SN1 reaction. This is the mechanism or course of reaction, that first the chloride leaves and then the ethanol or the lone pair of the hydroxyl that attacks the carbon, hydrogen is removed, and we get a substitution product. In this case, we have used ethoxide as nucleophile. Ethoxide is a stronger nucleophile, so it will give you an elimination product. This is the course of the reaction. Ethoxide attacks on the proton or the hydrogen, and the bond moves here between the two carbons, and the chlorine is removed in the sequence, and we get an elimination product. Then the size of the nucleophile. The size of nucleophile is another deciding factor in the course of the reaction, because if a nucleophile has bigger size, larger size, so it will be difficult for that nucleophile to attack certain groups or certain carbon atoms which are crowded. More is the size of nucleophile, more is the elimination, as it can easily approach the exposed hydrogen as compared to the hindered carbon, as the hydrogens are normally more exposed as compared to the carbon, which might be protected, or which might be in the cloud of hydrogens, or in the cloud of alkyl groups or some other groups, and it will be difficult for a bulky nucleophile to approach that hindered carbon. So the more is the chances of elimination in this case. Here, small nucleophile, hydroxyl, and the chances are here that substitution reaction may occur. Now in this case, the substrate is the same, but here we have a bigger nucleophile, potassium tributoxide. The tributoxide is a bigger group, and it will be difficult for the tributoxide to approach the carbon. So it takes the proton with itself, and the bromine is liberated, and we get an elimination product. So the size of the nucleophile determines the course of a reaction. A smaller nucleophile will favor the substitution reaction, but a bigger nucleophile or a bulky nucleophile, that will favor the elimination reaction. The strength of the base. Nucleophilicity and basicity are interrelated. They are similar. We can say they are similar but not identical, but fundamentally different. What is basicity? Basicity is a measure of how stable a species becomes after it has accepted a proton. It's a thermodynamic property characterized by an equilibrium constant Ka. Nucleophilicity is a measure of how rapidly an atom donates its electron pair to other atoms to form bonds. It's a kinetic property characterized by a rate constant K. For elimination reaction to compete with substitution, the attacking species must act as a base rather than a nucleophile. So this is a basic difference between the base and nucleophile. These two terminologies are interrelated, but there is a slight difference. Okay, basicity is a thermodynamic property, while nucleophilicity is a kinetic property. And the basicity depends upon the proton exceptions, that accepted a proton and then how much stable it is. But the nucleophilicity depends upon the electron donation, that how quickly or how efficiently it gives a pair of electrons to form a bond. So for elimination reaction to compete with substitution, the attacking species must act as a base rather than a nucleophile. Why? Because in the elimination, a proton is abstracted, The attacking species will extract a proton. So it will act as a base to get a proton, and then how much it is stable after getting that proton. The strength of the base is that how it works or how it affects the reaction, the course of reaction. Stronger is the base, so it will get the electron, it will get the energy easily. But weaker is the base, it will get the energy difficultly, and the end product is the same. The strong bases are in two categories. Big bulky bases. These bases are sterically handed and never acts as nucleophile unless the substrate is methyl or very small group. So these bases are very much bulky and they will just act as a base, never as nucleophile. In some cases, they will act as nucleophile. That cases are that when the methyl group are the most exposed groups carbon, they are in that cases it can act as nucleophile, but in normal situation it will act as nucleophile. It will act as base, not a nucleophile, like the tertiary butoxide, the new pentoxide, the lithium diisopropylamide, DBU and DBN. These are the bulky bases and they seldom act as nucleophile. They are mostly acting as the bases. The strong small bases. These act as both as nucleophile and bases. These are the small bases but very much strong, and these can act both as nucleophile and as base, like sodium hydroxide, potassium hydroxide, sodium methoxide, and sodium ethoxide. Some species may appear basic, but they will only act as nucleophile. The reason is that they are either polarizable ions or resonance stabilized species that are not strong enough Bronsted bases for the elimination reaction. Like these species, these are quite polarizable. These ions are polarizable, chloride, and these are resonance stable. This negative charge can come on this oxygen or on this oxygen. The same is the case here. So too weak for the E2 reaction. So they are appear like bases, but they will never act as base. They will act as nucleophile, and when be involved in the substitution reactions, not in the elimination reaction. The effect of temperature, how the temperature affects. Temperature has an important role to play in deciding whether a reaction is an elimination or a substitution. What happens in elimination reactions? In elimination reactions, we have two molecules, the substrate and the base, but it becomes three. In a substitution molecule, two molecules form two new molecules. The number of molecules remain the same in the substitution reaction. So, when the number of molecules are different, the two reactions therefore differ in the change in the entropy during the reaction. So the change in entropy is different for the two reactions. and then that will have effect on the proceeding of the reaction, and the temperature will have direct effect on these reactions. Delta S is greater for elimination than for substitution reaction. Temperature. Delta G, or change in Gibbs free energy, is equal to the change in the enthalpy minus the temperature and the change in the entropy. G is the Gibbs free energy, or the delta G is the change in the Gibbs free energy. Delta H is the enthalpy. Enthalpy represents the enthalpy of a system. Enthalpy refers to the sum of the internal energy of a system plus the product of the system pressure and volume. So enthalpy is the whole energy of a system, while S is the entropy. It's a measure of the disorder of the system. S can be used to probe the driving force behind a particular reaction. It is another factor that helps determine whether a reaction is spontaneous or not. So now if we look to this reaction shows that more is the change in entropy, delta S, more is the quantity of delta S, or more positive is delta S, the delta G become more negative. The delta G will become more negative. So at higher temperature, the delta G will be more negative. So therefore, at higher temperature, elimination will be favored, because the delta G will be more negative and it will favor the elimination reaction. And that's the reason that most elimination are conducted at room temperature or above. Or we can say that higher is the temperature, so more will be the elimination favored, and the elimination reactions are normally conducted at higher temperature. This temperature effect is due to entropy. Delta S of a reaction is more positive for an elimination reaction than for a substitution reaction. Like there is 2-bromopropane, substitution, 2 product. But in elimination, 3. So here is the greater is the entropy. Increasing the temperature of the reaction generally tips the balance in favor of elimination. Here, 2-bromopropane, sodium hydroxide in methanol water at 45 degrees centigrade. There is 47% substitution product and 53% elimination product. But the same substrate, the same base, and the same solvent at higher temperature, 100 degrees centigrade, 29% is the substitution product and 71% is the elimination product. So at higher temperature, elimination become more favored. When substitution and elimination reaction are both favored under a specific condition, it is often possible to influence the outcome by changing the temperature under which the reaction takes place. If all the conditions are the same in a reaction, and we can get both the products in equal amount, the substitution and elimination. So by changing the temperature, we can influence the outcome of the product. If we increase the temperature, we will get the elimination product. If we decrease the temperature, we will get the substitution product. All of these reactions have an E that needs to be surmounted. Heat will accelerate the rate of all reactions. The object is not to overheat to allow higher energy reaction pathways to compete. E2 reactions are more strongly accelerated by heat than substitution. Thank you very much. Thank you.